Okay, so we're just going to have a quick look at transformations on Trig graph. Again, this is for the basics of the National 5 course, so there is a lot more information, but we're just going to try and keep it to the key skills here. We're going to teach you all these skills through the sine curve, so you need to make sure you know what the sine curve looks like before we really start and you're confident with what each of those graphs look like. Each of these rules applies in the same way for the sine, the cosine, and the tan graph. So, if you look at general sort of the layout of a trig expression or a trig graph, each graph has an equation. Looks quite complicated. With a National 5, you're normally really only focusing on maybe one or two transformations at a time. So the value at the front is A, and then we also have a transformation value in front of X, another transformation value C here, and a final transformation value D. The A relates to the amplitude of our curve, so how high on the y-axis the curve reaches. The B tells us how many, tells us the period, or it helps us work out the period of the curve, how many curves are on the x-axis over 360 degrees, so more specifically. And then C, which is inside the bracket with the x term, is affecting the x shift, or an x transformation, and it tells us how far to the left or right the graph is moved. That's normally where people have the most challenge. And then finally, we have the value D. Notice it's outside, it's not associated with the x term, it's outside of that, outside the brackets, and it's how far the graph is moved up or down on the y-axis. It's called the y shift, up and down. Okay, so we're going to look at the two more basic ones. That's the amplitude and the period first, and I'll get a little bit more into this transformation and this transformation in a minute. So let's look at what we're affecting the amplitude. Now, there's a really good video that you will see, that'll be linked underneath to give you a bit more information about how that's used. But it's really straightforward. It tells us how high on the y-axis the curve goes. So you need to know that a standard trig graph goes up to a height of 1 and down to a height of -1. So now if we're asked to sketch y equals 4 sine x, we know now that the graph is just going to cover the same values along the x-axis. Nothing is different on the x-axis, 180, 270, and 360. We all know that already. And we know that our sine curve goes up to a height of 1 normally, and down to -1, up, back up, and up to, down through there, down, and up again. So our normal sine curve looks something like this, and we know that, and we're confident with that. Okay. So we're now going to look at what happens if we have y equals 4 sine. So what we do is we go up to a height of 4. And then back down. Okay? And then we're going to go down to a minimum height of -4. Nice and easy there. Before we turn back up. Right? So our new maximum turning point is 90 along a 4, and our new minimum turning point is 270 along and at -4. Again, you can do the same idea with a cosine and sine rule, cosine and tan, and you're just basically making it go to a new height of 4 rather than 1. Okay, so let's have a look at sketching this equation and this one. See if you can have a go at it yourselves. Again, bear with my amazing sketches, but we're working on that. Y equals 7 sine x means it goes up to a height of 7 at 90, passes through 180 at 0 still, and down to a height of -7 before returning back to 360 for a sine curve. And then for half, starting at 0, up to a half, through 180, down to -0.5, back up to 360. Now they are pretty low standard curves, but the whole idea, as long as you're given the key information and you're making sure you're marking on the x-axis and you're marking on your turning points, you're setting yourself up to get the key points across. Okay, so that is affecting the amplitude. That's the value in front of the function. So the amplitude tells us how high up and how low down it goes.